Next, I'm pleased to introduce our keynote speaker, Dave Wolter, Assistant Vice President, Radio Technology at AT&T. The title of Dave's keynote will be 5G, Can It Do the Splits? And so, welcome, Dave.
So hopefully everyone can hear me all right. Got a little bit of a cold going, so I'll try to make it. I think a lot of the points I'll make you heard in the last panel, which is a good thing. It's nice to see some level of gelling within the industry as to expectations. And what I'm really trying to get to with this discussion is the flexibility in 5G. So I think we've all seen the normal kinds of pictures that show the different things that 5G is supposed to do in terms of it's got to be better, it's got to be faster. And that's been the case with the previous generations of technology. We went from 1G to 2G, it's all about voice, right? More voice capacity. 2G to 3G, again, it's all about voice capacity, and okay, we start to bring a little bit of data in there. As we move from 3G to 4G, it's like, okay, data has become more important now. We used to have this saying back in the old CD/PD days, data was the trend of the future and always will be. But it actually arrived. And so as we looked at LTE and moving that way, that was really a focus on increasing data. As we move to 5G, the thing that I think is very different about this is that we're not taking sort of one capability, one use case, thinking in one direction and trying to move it to, okay, let's get even faster. Clearly that's a need, but that's one of the needs. We see many other things that are coming into play now with massive IoT and with critical IoT, which has been discussed. So I wanted to talk a little bit about some of the standardization work and some of the requirements and expectations I think we have of 5G. And then I give just a quick overview on some of the trial work that AT&T is doing. So we've already had, excuse me, a bit of discussion on the standards, right? So 3GPP phase 1, release 15, we're looking at happening in 2008, with phase 2 in 2018. Phase 2 at the end of 2019. And these seem to be splitting up kind of the functionality with a great deal of focus on millimeter wave, partly for the things that are going on in Asia and those demonstrations that need to happen at the Olympics, and a lot of interest in the US and elsewhere on how can this be used to improve the performance of broadband to the home in those places where it's really hard to get fiber, right? So we see these two different phases and emphasis that is different. So phase 1's really going to be emphasizing that millimeter wave, some of the fixed access, some of what's going to be needed for the demonstrations at the Olympics in Korea and the Olympics in Japan. And then phase 2 would pick up and do more of the work on some of the massive MIMO, the critical, or massive IoT, the critical IoT. And then we really see, widespread industry deployment starting to happen in, phase 2 and beyond, so 2020 and so forth beyond that. These have very different requirements, as we've already talked about, right? Part of it, we want throughput that's in the gigabit per second range. In other places, we want to talk to devices where it may be 100 bits once, twice a day, okay? And we want to have battery life in those devices that lasts for 10 years or more. And we want to be able to do things that require very low latency for real-time applications, industrial control. I always shudder when everybody uses the example of remote surgery. I'm not the guinea pig for that one. But when you start thinking about that, industrial control, remote manipulation, and so forth, the latency, of course, is critical. And where it'll probably end up being the most critical is in gaming, right? That seems to drive a lot of the requirements for computation and latency. So what does that mean? It means that we need a very highly flexible RAN design. I can't look at this up front and say, well, I expect 20% of my capacity to be this, 30% to be that, and 50% to be this. And so I'm going to design and build my network that way. I'm going to have multiple radio technologies optimized for each one, maybe different radio heads or some kind of radio head that integrates all these things. I can't do that accurately up front. I need to be able to address my market in a dynamic fashion as we move forward. So here's where, I got to thinking about what does this mean for the system? And we've all kind of seen the jugglers, right? And they're juggling the balls, and then they do the splits, and they show you how incredibly flexible and precise they can multitask and do different things all at the same time. Well, that's kind of what our network's going to have to do. We're still juggling the balls of LTE and trying to keep evolving that. We're trying to look at these different use cases and make sure that we can do all of those things. And we want to do that on the same radio. So it's got to be a very flexible system. I think a lot of this has been covered as well. This is sort of where the timeline seems to stand right now. We've heard a number of different announcements about pre-standard based systems that will be deployed either in trials or maybe in pilot deployments. Those pilots then could end up evolving to a standardized deployment. We may see that evolve in place. So we'll see a lot of pre-standard work done in the network and in the field, starting probably next year. We'll be starting some lab work and trial work, certainly even this year. But then we'll see, I think, the focus on the enhanced mobile from, the end of 2018 and on, as is being driven today by much of what's going on in Korea. And the full standard, end of 2020 and on is where I think we can start to really see that happen. And as we mentioned in the previous discussion, forward compatibility is going to be really critical. So one thing we don't want to do is get really focused on phase one, enhanced mobile broadband, really get good at optimizing for that, making decisions about that, decisions on layer one, layer two, how am I going to do the numerology, and so forth, and then find in phase two, oops, we made a decision in phase one that kind of caused us a problem over here. We've got to be thinking about all of these things at the same time up front to ensure that we don't do something that precludes that flexibility and that forward compatibility that we're going to need. Okay, and if anything, that's probably my main message today, because it's very easy to get very focused and solve a problem, but doing it in a way that just isn't flexible enough. So at the same time, yes, we're all focused on this path to 5G. And we're focused on, all right, how do we handle spectrum below 6 gigahertz? How do we handle millimeter wave? How do we do beamforming and tracking and whatnot? We have to remember not to forget LTE advanced. And as was mentioned, there's work going on there, a lot of new items that are being put into place for release 14 and on. But it's going to be important for us to be able to bridge the gap in what we anticipate getting with 5G, with what we can really put out there in their nearer term with LTE. It's also going to take a long time to roll out 5G and talk a little bit about the different components of it in the lower frequencies and the higher frequencies, but it's going to take time to roll that, and so we got to keep increasing the capability of the network that we've got. So that means things like full dimension MIMO and being able to go into existing spectrum or new spectrum, if there is any new spectrum. That's getting harder and harder to come by. And being able to use full dimension MIMO to increase the capacity that we've got in those bands. We're all densifying our networks. The appetite for data is just insatiable. And so we're densifying our networks with small cells. And we need to be sure that we can manage those well, that we can do the layer management, the load balancing, do all of those things in an intelligent way that lets us really maximize the capability of those networks. We want to do dual connectivity so that we can not only maximize the capability of the small cells we put in place today, But if we're putting that infrastructure in place, I would anticipate that many of those same places are going to be the places that we want to have our millimeter wave small cells for 5G, right? So we would want to be able to use dual connectivity and other techniques to link our LTE Advanced and our 5G and increase performance. There's talk of improving latency within LTE. It's not going to get to the level that 5G does, but there may be some ways that we can improve that. We can move to higher order modulation in small cells, and in particular indoor, where we can provide higher throughput. There's the use of unlicensed band technologies that we'll see used both inside and outside to help increase speed. And kind of go in the other direction then, IoT is rising very rapidly. The connected cars, smart cities, all of these kinds of applications that are coming to the fore now, some of those require a lot of data. Some of them require just small amounts of data. But today, the cost of the modems, if you're at LTE and we're shutting down our GSM network, so those people who were using GSM modems for IoT, now what are they going to use? It's more expensive to use a 3G or a 4G modem. It's less battery efficient. So we're working to solve that capability by looking at things like narrowband IoT and Category M. So there we're going to try to solve some of the problems of the low power devices on long battery life using narrowband LTE. Standards will be set this summer, and we're anticipating deployment late next year and early 2018. But is that going to solve all of the problem? Well, probably not, right? It's still based on LTE, and it'll get us a good part of the way there. It's still kind of a connection-oriented capability with the limitations that brings with it in terms of the number of devices that can be served. So we've got to be handling all of these things at the same time. We put an awful lot of our emphasis over in the 5G area. And as we've said, 5G is a lot more than just more speed. Clearly, we want that multiple gigabit per second and the high capacity. And in particular, we're going to see a lot of small cell implementation to make that happen. But we also want connectionless massive IoT. Well, that seems to be more focused on the lower bands, right? And the ability to do that in a fully connectionless fashion and serve hundreds of thousands of devices, perhaps in a cell site. So that's, and then that's laid on top of the ultra low latency capabilities. So all of these things are expected to be addressed by 5G, not just speed, where the focus is today. So we'll see sub-6 gigahertz, I think, both for LTE evolution, just to continue to evolve and be more spectrally efficient, but also to let us really spread that IoT capability over time. We need a flexible lean carrier design to make all this happen. We want to do this within the same radio design. And we're not talking about just one RAT. So we were talking here a moment ago about, all right, can you design the same RAT that works at sub-6 gigahertz all the way to 40 gigahertz? And that is being developed for 5G. But in my view, 5G is more than just this new RAT and a new core network behind it, but it's also how do I use the existing RATs in order to look at this as a complete system. So I want to use LTE. I want to use unlicensed technologies. I want to use whatever makes sense as part of my total system view. So our new core network has to be able to interface with these different radio technologies. So it needs to be as access agnostic as we can make it, so that I can bring these in and make intelligent decisions about, okay, Wi-Fi is available right now, not heavily loaded, let me put some of this over here. That application needs low latency, I got to do it this way. I have IoT devices, I'm going to put them on that sub-6 gigahertz RAT and do that. So all of these things need to be part of the way we think about 5G, and it's a different way of thinking about it than it has been in our past generations. Now to us, all of this, number one, it's going to be very dense deployments, and lots of fiber is going to go out there, but we need to be thinking about the use of self-backhaul as well in order to make those deployments more cost-effective, and to perhaps to get them out there temporarily and then follow on with fiber. And all of this, we think, is really going to be helped or is going to be driven by the need for SDN NFV architectures. Because again, as we talked about at the very end of the discussions there in terms of, you know, radio disaggregation and network disaggregation and placement, you know, mobile edge computing and so forth, what it really gets down to is an architecture that can be flexible, where I can put the computing capability, the storage capability, the functionality where I need it. And that may change from time to time. So we need an architecture that will allow us to dynamically locate different functions. We talked about the different frequency regimes. Sub-6 gigahertz we understand pretty well in terms of the channel model. We get wider channels out of 5G if we can find the spectrum to use that. In the places where we use existing spectrum, at least, you know, we want that to be a little more efficient and to do our IoT optimization. Millimeter wave is a bit of a new animal for all of us. And of course, that's where an awful lot of the discussion lies, where an awful lot of the public information lies, because that's new territory. And of course, for engineers, it's always fun, right? New territory, we get to think about new things, talk about new things. So we've got to think about the propagation characteristics, and it's not just the propagation itself. It's all of the small scale parameters that go with the channel that we need to really understand, so that we know how we can model these systems, and therefore how to deploy these systems, right? Going to have extremely wide channels. It's going to be different. We're going to have a different way of thinking about things like interference analysis. So now we're doing beamforming. Okay, before we were thinking about sectored antennas that spray out energy reasonably evenly. We worked up ways to handle that. We understood how to handle that and did our deployments based on that. Well, how do we do this differently now when we think about the fact that all of these base stations have beamforming capability? There's got to be a way that now we can enhance that capability, because we don't have equal energy going out everywhere. So part of that gets to the way we think about and model the beamforming. Part of that gets to the channel models that we have to develop. A lot of channel modeling has been done in Europe and Asia, or measurements. Less so perhaps in the US. We need some more work in the US to help make sure that the channel model incorporates the parameters that represent our environment as well. So this is just a few of the key technology building blocks of 5G, and I think most of these are pretty obvious, and you're going to hear more about some of this from Arun this afternoon. But clearly, splitting the control and the data is going to be important. The use of dual connectivity in order to make sure we have that reliability of connection. So I'm connected to either a sub-6 gigahertz 5G or maybe it's LTE, while also taking advantage of the 5G coverage or millimeter wave coverage where I have it. Being able to use self-backhaul in those places where it's difficult or expensive for me to get fiber to a given location. Clearly, different spectrum bands that will be used here. Massive MIMO, and the use now of something more like a UE-specific virtual cells, as opposed to using specific sectors all the time, right? We want to create a cell that's really focused on that UE. And the flexible carrier that can handle all of these different use cases at the same time and has a flexible numerology. Now, many of these components, like the dual connectivity and the massive MIMO in the form of full dimension MIMO, some of the spectrum sharing issues and all are being done now for LTE. So we can prove out some of these technologies as part of LTE and then move them into 5G. Okay. Now, we also need to consider the fact that 5G is not just a RAT. It's not just a new radio. We're going to have a new core that goes with this. We need some different capabilities within that core. We need low latency capability to take advantage of the real-time applications. Going to have very different requirements, just like on the radio, right? The IoT is going to have a very different set of requirements than does the enhanced mobile broadband. The core has to be able to work with those different capabilities and optimize. So we need flexibility in the core network design and operations, just like we do in the radio. And here, concepts like network slicing become important. So I can end-to-end optimize the way I'm addressing a given device, right? So I have an IoT device that has certain needs. Well, back here in the core network, I may not need to worry about mobility, right? So I set up a very simple back-end core for that device. Maybe it's very low latency due to the application. When I go to enhanced mobile broadband, if it's talking to the home, again, I don't need mobility there. So why should I be paying the penalties, the overhead, and the price for doing that when I don't need to? On the other hand, if I'm doing enhanced mobile broadband to a tablet-type device or a car or something else, all right, now I've got to have all the capability around mobility management that are needed for those kinds of applications. Now, again, I can't reliably predict what I'm going to need, when I'm going to need it, and where I'm going to need it. And that's where software-defined networking and network function virtualization becomes important to me. And I think about how do I dynamically allocate those things at any given location. And there was a mention earlier of OpenStack. We do have a drive towards as much open source usage as we can. There will be places where open source doesn't make sense. There will be other places where it does, and we have to be very intelligent about how we do that. Okay. Big data is also going to be a big part of 5G. An awful lot of this dynamic and intelligent load sharing, setting up of different network slices, all of these kinds of things are going to be based on data analytics that are happening in real time. And then there's also going to be all of the normal kinds of network planning and capabilities that will need maybe not real time, but big data kind of applications that let us do that more effectively and more efficiently. So some of the core network requirements, there's got to be a new RAN to core network interface. And I guess what we've termed mobility on demand, right? So we set up network slices based on what they need, whether they need mobility or they don't need mobility, whether they need very low latency or they don't necessarily need low latency, depending on what kind of transport technology happens to be available to them at that given location. You know, it may be a place where we want to do certain things and we're trying to provide certain applications, but because of limitations on what we had available to us in terms of transport, we may have to do things a little differently. You don't serve a given application, or I might split my functionality differently in that particular location than I do in another location. So we need to be able to do that. Mobile edge computing is another good example. There are a lot of good reasons to think about mobile edge computing, but do you have to have the same configuration and capability in every single location? Maybe not. And do you have to do it all the time? Again, maybe not. So we've got to think about that. And the control plane, we want to make sure is separated from data plane. So that's part of the purpose of the trial work that AT&T is doing. My team, a big part of them are here in Austin, and we'll be extending the kind of testing and work that we're doing in our lab now, excuse me, to look at 5G. And we've kind of looked at this at three separate kind of tasks, and Arun talked a little bit about some of this earlier. One task is channel sounding. So there's a lot of work going on in 3GPP right now. You might say, well, you know, that channel sounding work's going to be done shortly, and that's true. But there's the channel sounding model that they put together, we want to be sure that that model really reflects our channels, our locations, the kind of things that we're going to need to do for our own internal modeling. So we'll be doing some detailed channel sounding in multiple different environments and in multiple different times, right? So you think about weather impacts and foliage impacts and so forth over time. We will also have a test bed in place, and this is intended to stay in place for years, that will let us work with our vendors and internal systems development to look at things like the different frequencies in use, the sub-6, millimeter wave, look at different antenna technologies. We'll be able to look at that from an outside to inside, macro kinds of coverage, propagation and throughput characteristics and so forth, fixed and mobile. So these are all things that we want to look at with a test bed that's not just, all right, let's go ahead and demonstrate that and take it down. We want to keep bringing new capabilities to it, new algorithms to it, whether that's a vendor algorithm or something we develop ourselves. Try it out, see how well that works. Take some of those learnings back into 3GPP, take some of those learnings into our company where we can be doing the planning, getting ready for this. How do you deploy a network like this? And then towards the end of the year, we'll be doing a friendly user trial focused on fixed broadband at 28 gigahertz. And here we're looking at providing, gigabit per second plus connectivity to fixed users. And, as I said, thinking about those places where maybe we can't get fiber to the customer, but everybody's desire for increased speed keeps rising, right? ADSL just doesn't really cut the mustard anymore, so we need to keep raising that up. So our next steps then are the trials and the testing that we're doing, standardization support, looking at these key architecture components, the NFV, the SDN, how do those impact the way we think about design of a radio system and the total overall architecture? How do we use big data and analytics in this new environment? And that goes for LTE, not just for 5G. Architecture considerations. How do we think about where those functions are placed and how you determine dynamically how much I need here and how much I need there? Where does it go in my architecture at any given point in time? What are the transport considerations and the transport planning that need to come into that? And then the core network development, and I don't know a lot about the core network development, so it's got one little point there. But there are other folks that are working just as hard, of course, on the core side as all of us are on the RAN side. And we need to then, of course, bring those two things together and make sure we're looking at this in a full system fashion. So, as John Donovan, our Chief Strategy Officer, would say, our approach is simple, or sounds simple. Deliver a unified experience built with 5G, software-defined networking, big data, security, and open source software. Easy to say, not quite so easy to do. He thinks it's a simple approach. But that's the way that we're attacking this problem. And it's going to take time, and just like any other generation of equipment, it's not all ready day one. We'll come out to each one of these releases. They'll have some subset of capability that we're all trying to create, and we'll continue to evolve that over time. So with that, if we have time, I can take a couple questions. Yeah.
Thanks, Dave. Hey, I can speak without the mic. So quick question for you on the control plane. You mentioned it briefly. How do you envision the control plane shifting in 5 years relative to the way it's currently architected? Particularly, how are you dealing with massive IoT?
I may not be the right guy to talk about that so much, but the separation of those two will be important to be able to optimize the performance of the network. The architecture that will fit in once we can separate control and data is going to look a lot more like what we're trying to do as well on the wireline side. And so you might want a consistent network architecture that runs through your wireline side and your wireless side. Yeah, there are other folks we can get together later, and I can get you with other folks who can talk more intelligently about that. Yes.
You talked about the indoor and outdoor test beds and virtual cells. Can you elaborate what's the virtual specific cells or something?
Yeah, thinking about UE-specific cells, so that I'm determining what I need to do and the performance I need to give to a particular UE instead of thinking about it as a sector. So yeah, it's UE-centric. Yeah.
So given the concerns that were already highlighted around antenna miniaturization, do you have a sense yet of when you'll start to see devices that will be outside of the kind of hotspot, the kind of personal hotspot kind of?
You're talking about user devices?
Yeah.
Yeah. I think what you'll see first are the fixed devices, right? So if we're thinking about broadband to the home, that could be something that looks sort of like a modem that sits on a desk or sits in a window. It could also be an outdoor device that's attached to the side of the home or on the roof. Those I don't think are that far off, depending on the business case and whether somebody's going to pay the supplier to operationalize that. Getting to something that's smaller, it's more of a handset form factor. We understand that there may be some things that are done that way, even for the Olympics in Korea, but that'll be, those are kind of one-offs, right? When is that going to be available in a big way? I'm guessing it's more like 2020 and beyond. Get back here.
Steve Kovacic from Skyworks. So we're in the early innings here for 5G, it seems, but Dino 2.11, Wi-Fi just keeps chugging along, and to what degree do you think the millimeter wave part of Wi-Fi will sort of cannibalize the use cases for 5G? I mean, as a front-end supplier, we see more and more chipset vendors now coming out with tri-band Wi-Fi solutions. That might be integrated in that.
Yeah. In fact, we see them as complementary, not as competitive. There are going to be places where it makes great sense to have Wi-Fi in place. We use it today. We're a large Wi-Fi operator today, and we don't see that changing, particularly in the enterprise space, where the enterprise will want to have control over that Wi-Fi, but may also have something, a provider that's providing 5G voice and data services within their enterprise as well. There are a couple of ways of attacking that. One, you can integrate with them in terms of the Wi-Fi, or two, you can do it as sort of standalone, in which case it might make sense for us to use the Wi-Fi millimeter wave. But I think both of those things are going to go forward, and both are going to be complementary to one another. Anything else? Yeah.
For the initial 5G broadband to home services AT&T is going to launch, is it target for rural area or urban suburban area?
I'm sorry, I didn't hear the last part of that.
For the service, right? For the initial 5G service, broadband to home service, AT&T is going to launch in 2017. Is it the service target for rural area or urban suburban area?
I think we're going to look at all of the above. So it can certainly be for, think about suburban areas where today we don't have fiber to the home. We have maybe IP-DSL, but we want to increase the speed. We might use it there. You think about MDUs in a more urban environment. That would be another place that we'd think of using it. Rural gets to be a little more difficult just because of the density, but there may be places where that makes sense as well. So we're looking at all of the above. We haven't made a decision on exactly how that would be done. And my guess is when we do that deployment, that initial set of pilots, we'll pick multiple environments so that we can learn from them. Okay? Yes?
Hi, my name's Eitan Schwartz from RAD. I have a question. You mentioned higher reliability, but we didn't discuss at all timing considerations in the LTE Advanced or the 5G. And I'm thinking along two lines. One, typically in the US you use GPS, and so backup in case of jamming or interference there. And on the other hand, extending timing out to small cells where you may not have Skyview.
Yeah, it's not an area I know a lot about, I will tell you. GPS is used, 1588 is used. Beyond that, I couldn't give you a whole lot. I can get your name and we can get someone in touch with you if you like. Yeah, sorry. Any other questions? One in the back.
Maybe I can just project. You mentioned earlier in your presentation about this new sport and it needing to be flexible in terms of different capabilities.
Yeah.
Does AT&T or are you helping to define the technology that will allow you to be flexible? Or can you give us a little more information about what this technology will look like?
In terms of the radio technology itself, or are you asking about more of the use cases?
Well, the radio technology itself, and maybe in particular the baseband unit.
Okay. We're participating in the standards and we're working with our vendors. We're not doing designs that we're then going to bring into 3GPP, for instance, but we do work with our vendors closely on what they're doing and provide our feedback. We do the same thing with use cases, try to define those use cases, make sure that what's being proposed can handle them, or we make a decision not to handle them, right? But we do that more in partnership with other providers and with our suppliers, as opposed to just bringing something in on our own.
Thank you.
Okay. Okay, thank you.